Good morning, everyone. Thank you for joining today's EAC webinar. This is Cassie Stumo. I am the marketing specialist at EAC. We will begin today's session with an introduction of EAC, and then Todd Liebenow will be talking to us today about the Creo extension called Creo Product Insight and how you can use live data to predict product behavior and performance directly within your CAD model. This session is being recorded. Unless there are any technical difficulties, everyone will receive a replay after the webinar. Please feel free to drop questions in the queue as we go, and then we will answer them after the presentation. So I do see a few familiar names, but for those of you who don't know who we are, I'll start off with a quick introduction to EAC. Our mission is to transform the way companies design, manufacture, connect to, and service their products. We are a solutions provider for PTC, offering our customers products such as service lifecycle management software to help create and manage service documentation, product data management software like Windchill and ThingWorx Navigate, which helps organizations manage their internal product data. And then we also implement the Internet of Things and augmented reality into business strategies. We also assist with design and engineering projects, and then we offer training courses and webinars for continuous learning. We are also a commercial reseller for Formlabs 3D printers, so we really have a variety of tools to help your organization save time and money. So please keep us in mind when it comes to your product development needs. I'm going to go ahead and pass things over to Todd, who will be giving us the demo today.
All right, good morning. I'm going to push the share my screen button and let me know when you've got that.
I've got it.
All right, great. So good morning. What we're going to do today is talk a little bit about a simulation here. I've got a part of a suspension for snowmobile, and we're going to look at some things we can do here. First off with the mechanism, right? So we can go ahead and put different motors and things on our mechanism and create some simulations that way. But what we're talking about today is kind of going beyond that and connecting that up with sensors and getting real-time data back from these sensors and showing the influence of this thing working in its environment and getting feedback as far as performance and sort of instrumenting the model and getting some performance characteristics as far as how this thing is behaving in situation in real life. And so to do that, we're going to be taking advantage of the Internet of Things. You probably heard about that a little bit. What we're going to do is replace these assumptions that we're making inside of our mechanism simulation with real-time data that we can get from the sensors that we could put on the machines, and then kind of connect to the ThingWorx platform and show how we can utilize that information back in our CAD model. So to start off with, we've got a little mechanism put together. We've got a motor here. I'm doing this in Creo 5 just as a point of reference. So we'll go ahead and take a look at our motor definition. And if we take a look at our profile details here in this case, we can see that we've made some assumptions here. We've got a table-driven motor. So in this case, we've got little timestamps along the way, and we've got the driven quantity for that. If we graph that out, we can kind of see we've got sort of nice little plot for this servo motor that's going to drive our mechanism through its range of motion. But this is us actually sort of making some assumptions about what's going to happen over time as this ski runs over a bump in the snow or something like that. So this is some assumptions that we're making about the performance of this, not actually using any sensor data to start with. So to go ahead and get started, this is a little bit different type of assembly in that this is what's called an instrumented assembly. So if you're just to show you how this works, this is an assembly and this is a new type. It's an instrumented assembly. And what that does, if we go ahead and select this instrumented assembly, when we go to our tools tab, we're going to find that we now have a section here in the ribbon for sensors. Right, so this is this instrumentation aspect of creating our assembly. So we'll go ahead and just create a sensor, and what we're going to do is just assemble this. Right, I've got a couple of different types of sensors. I've got a suspension component. Right, so we'll just go ahead and grab this guy. And what this is going to do is basically put on the physical component of the sensor. And I'm just going to match this up with the coordinate system from the component that we're assembling in, and we'll just assemble this back to that coordinate system for our component in the assembly, right? So we'll go ahead and just place that in the assembly. So that's the first step. We just basically place that object in, and notice that's going to show up here in our model tree. So now we've actually got that component assembled just like a regular part in the assembly. And then if we go ahead and take a look at this, we'll go ahead and take a look at the definition of this. If we look at the parameters for this, so now we see we've got a travel parameter here, and we're going to just change this. It's just a regular parameter, but if we go ahead and take a look at this, we're going to change this to a series type parameter. So this is where we connect up the parameter information for that sensor back up to our it's a different type of sensor, right? So it's a different type of parameter. It's a series, and this is really what helps us establish that connection back to the ThingWorx platform, right? So now we can say this is a series type parameter, and that's what establishes that connection back to that sensor on the assembly back to our component on the ThingWorx platform. So we'll go back here and we'll edit the definition of this. And now we're going to go back and take a look at the sensor. So right now we've basically assembled it, and now we're going to go back and define that. So here's where we're connecting up that parameter back to our connection. So now we're just going to say here, we're going to go back to the feature and go back to our motor. And here's where we establish the connection for that physical sensor back to that tabular data. So we just go ahead and insert this, right? And so now we've actually got that tab connected, and so our sensor is connected and we're set to go. So that's the first type of sensor. That's the physical sensor. If we put in another type of sensor here, we'll put in a virtual sensor. In this case, we're just going to grab this one here, and I'm just going to go ahead and say right now I'd like to just place that as a note, assemble it, and I can either have it as a note that's got a leader attached to it or not. Either way, in this case, I'm just going to have that the attribute there showing my virtual sensors, and it's just sort of a note that's free floating, and you can just have that assembled there, place that in the assembly. So if we go back and look at our virtual sensor, now we'll take a look at our sensors and look at the parameters for that. Now I've got three different sensors here in this case. In this, I'm going to go ahead and change this just like I did before back to the series, so I can establish that connection, right? So just changing the type of parameter. If you think about it, there's typically 4 different types of parameters. We have string type parameters, integers, real, and then binary, yes or no. This is just the different typeset for the parameter that we're making this a series type parameter, so we can establish that connection back to the real life sensor data. And then just as we did before, we're going to go back and edit the definition of this to go back here to my sensors. And I'm just going to make a connection now. So really what we're doing is we're looking at the information for these ball joints. So we're looking here what's happening at the ball joint at the top, the center portion of this lower arm, and then down here at the lower portion where the this connection ties the ski back to this control arm. So we're just going to go ahead and define this connection. And all I'm doing here is I'm just going back and pointing back to that feature that we just created, right? So we're going to go back here to this sensor, back here. Oop, hang on just one second. Cancel out here. I've missed one step along the way. And let's see here. I just want to go back and change the sensor guy right here. Select this back to our feature and point back to the motor. And in this case, I want to point back to the series. Oh, yep, the step that I think I missed here is I think I need to go back and run my motion analysis first, right? So let's go back and do that. Go back here to my analysis. We'll just do a quick motion analysis for this. Yeah, this is the piece that I missed here. So I just need to run this. So this is where I'm actually creating up this connection here between these 3 different sensors, or these 3 different connections rather. And I need to run that first. Yeah. So that's why I couldn't connect that, because there's no result parameter to connect to just yet until this simulation is done, right? So now that we've done that, So here's the different connection reactions at these different locations in the model, and I get a very similar result for the 3 locations. All right, so now I've got that. We can go ahead and add that as a feature. This is the piece that I missed. I need to create that as a feature, and that's what I'll connect back up to with my virtual sensor. So we'll go ahead and accept that. So now we have that, and we'll just go ahead and say, I'm just gonna reorder that here. So now when I go and edit the definition of this guy, now we can go back here to my sensors, and now I can go back and define this here. Now I've got a parameter that can connect up back to. Here we'll say I'm going to point back to this analysis feature, and notice I've got these 3 different reactions here. So let's kind of stretch this out so we can see. So I'm looking at what's happening here at this connection, right, at this first one there. Then I'll do that again for the other 2 sensors, right? So we'll define this connection. Again, we'll just point back to that feature right here. And we'll do that for the final connection right here, selecting that results parameter from that feature right here. All right. So now that we have that set, the next step in the process would be to publish those sensors, right? So back here on my tools, so I would have a connection back to the ThingWorx platform. So what we would say is we would connect up to the server, or I would publish that information, or basically say, okay, I want to actually integrate or have this sensor be able to share its information from the snowmobile out in the field and transmit live data back to the ThingWorx platform, and then have that results information be available to me as a designer, right? So that's going to look like this. So I've got this ThingWorx platform where I'm actually using a mashup, and you can see in this case I've got this front suspension model, and I've got analysis events here. So if I just go ahead and log into this, this is the results from this front suspension, and I've actually played this back and captured the data. And I don't actually have a snowmobile here in the office, but what I can do is actually share that information back and track that in and bring that in as a CSV file. But you could either share that data back in real time through the ThingWorx platform, or have it capture the data and save that back out as a data file that we could read back in and look at the results from that performance in the field. And so what we'll do here is we're going to actually load that data in from a file. And I've got this CSV file, which was created as a result from this test run out in the field. We'll open that file up. And so this is the suspension travel information right here. So these are the timestamps for that ski as it's going over bumps in the field, and we can go ahead and run that, and it's going to populate the rest of the sensor information for the different joint locations in the model, right? So we've got this information now for the different sensor locations, and we can go ahead and close this. And when we go back and look at our simulation for this now, you're going to see that that data is now being driven from this tabular data as sensor input, as compared to just our assumptions that we've made from the data that we created for that servo motor as input. So we went back and took a look at our results. And in this case, we're going to look at the virtual part. We go ahead and take a look at parameters in this case. So here's the input. This is coming in from the model from the ThingWorx platform. And let's go back and look at this. We'll show you the results for that. And so we can graph this out. So here's our information from here, right? So this is now the information that's coming from the real-time performance from the snowmobile out in the field. And then finally, if we go to our applications, and we'll look at this in the mechanism, and now we can go back and do a playback of this, right? So we've got this analysis that's been run. So we can go ahead and run this and see how that ski is going to actually move, and that suspension is going to change its location. And then we'll do one more step here. We'll actually define how this is going to be displayed in the window. Actually, one step before that, I'd like to say I'd like to display the arrows. In this case, I want to show the reaction information for the measures at those different joint locations. And now when we go ahead and play this back, right, keep an eye on these different arrows. There's going to be 3 arrows that are going to change size as that assembly goes through its range of motion. You can see that the forces or the reactions at those different joint locations are going to change in magnitude as the ski goes through its range of motion. So that's really it. In a nutshell, what we're doing is we're instrumenting the model in Creo with sensors, and then collecting information from that object in the field, and either sharing that information in real time back to the designer as sort of a digital twin, or we can show the results from that model as bringing in the data sort of a test file and using that to drive our model through its range of motion, as opposed to making some assumptions about what's happening and sort of creating the servo motor in that fashion.
Awesome.
So questions?
I don't have any questions in the queue so far, just a hello from one of the attendees. But actually, what is the difference between physical and virtual sensors?
Yeah, so that's a good question. If we went back here, let me close this out. I won't save those results. We'll go back here and take a look at that, right? So there's a couple of different types of sensors that we can use, right? So we have a physical and a virtual sensor, right? So physical sensor is like the something you're actually going to assemble into the model, right? So it's going to show up in the bill of materials. It's just like the physical object or sensor that you're going to put on or bolt onto the assembly or whatever. They're going to have mass properties, and they're just like any other component that you might have in your assembly. A virtual sensor, you can think of that more like a feature that's going to be in the model. So there's not going to be a physical component in the assembly. They're going to have parameters, and they're very similar to an analysis feature, if you're familiar with those from behavioral modeling. The data that are used in the virtual sensors are always going to be calculated as compared to like a physical sensor. That physical sensor is going to read something from the environment. It's going to read a temperature or a pressure or velocity or acceleration or something like that, where a virtual sensor is going to generate its information. It's going to calculate that based on what's happening in the model.
Good, thank you. I don't see any other questions in the queue, so if there's anything else you want to show, you can do it now. Otherwise, we'll wrap it up and give everybody a little bit more time back to their day.
Sure. Yeah, it's pretty powerful stuff, but just to kind of get started on it, it's pretty easy, right? I mean, you just need to create that new type of assembly, which is going to give you access to the different types of tools. And then the other piece of that is you'll need the ThingWorx analytics or the ThingWorx platform to connect up to, so you can actually capture that data information and then bring that back into your Creo model.
Okay. A question did come in. What models and servers, or sorry, modules and servers would need to be in place so that all of this can happen?
Yeah, so there's a couple of pieces to it, right? So the first piece is going to be the Product Insight Extension, right? So that's going to be the piece that actually functions or gives you this functionality here inside the ribbon and that new assembly type. So that's going to be a Creo type extension. Then on the ThingWorx side, we're going to need some of the ThingWorx platform functionality, and that I don't have the specific details on that. I can find that out, and we can certainly email that information back out. But that's the tools that's going to give you this ThingWorx Composer, right? So at a minimum, it's going to be the Composer, which is the tool set that you use to create the different mashups and the different exchange of information, the different platforms, whether that's something like excuse me, Bluetooth or ANT plus or cellular, right? So there's different communication protocols that you can use to talk to these different servers or sensors rather, and you use the ThingWorx Composer platform to develop the mashups and then connect up the objects and then display the information.
Good. I hope that answered your question. So yeah, I don't see any other questions in the queue, so we will wrap this up. Thanks so much for joining us today for our webinar on connecting live data to your CAD models with the Creo Product Insight Extension. You will be receiving a replay of the webinar shortly and some details, like Todd was saying, what do you need in place for this extension to be able to use this extension. So please reach out to Todd or I if you have any questions, and watch out for future webinars, which you can find on eacpds.com/events. So have a great rest of your day, everyone.
Thanks. See ya.